Thank you, Mark. Thank you, Mark, so much for the worst intro today. I think it was an excellent intro. And first of all, ladies and gentlemen, it's a really great honor for me, as you have heard, with a shabby education coming somewhere half from Greece and Germany, and now being allowed to stand here on stage at MIT at the Media Lab and then present in front of you. I've never been here, so thank you very much for having me first. Thanks, Mark. And Mark asked me to talk about IoT in the sense, your motto was, the future arrives, yeah? Yes. And he wanted to let me talk to you about, since we have so many customers in the IoT space, did the future already arrive, or is this all still about a buzzword? And I thought, okay, that's a great starting point, and buzzword. So IoT started as a buzzword. When I introduced myself in the beginning, I always introduced myself as the VP of the buzzword. And I mean, there are others. I don't know which ones you use when you talk about IoT. I just put some out, edge computing, machine learning. I think we have something about blockchain coming afterwards. There's a ton of them which people just toss around. And again, the reason was, why do you want me to stand today here was, maybe IoT is less of a buzzword today. And what we have heard and what I liked with many of the speakers beforehand is, we do this for a reason. And at Amazon Web Services, when we start engaging with our customers, we want to level all of this with the why question. Why do we do this in the first place? And we typically start with this question to our customers, asking, if you knew the state of everything, of all of your assets, of all of your machines, of all of your factories, and you could reason on top of that data, what problems would you solve? And I will show you in a minute a few of the deployments that we have today, which solve some really serious problems. But the two conditions, knowing the state of everything and being able to reason on top of the data, is unfortunately not trivial. It's actually very complicated to get there. And we made it, in that sense, if you like, to our mission at AWS to make these two conditions come true. And I wanted to start giving you some evidence why the future has arrived for IoT and why IoT is not a buzzword anymore. And in order to make IoT work, let's start at the roots. There are two fundamental things which had to come together. And of course, since I worked almost my entire life in mobile, so that's where I grew up, of course, the mobile revolution had something to do with IoT. And I mean, I worked for Nokia. Some of these pictures are actually very close to the phones that we built and we sold billions of those. But what you see here in miniaturization was that the technology disruption of course mobile was you didn't need a cable anymore. Now you can communicate without a cable. And if you don't need a cable, then magic can happen. And at the same time, in the beginning, you had these big phones around your shoulders, and then they went smaller and smaller and smaller, and they went smaller and more cheaper because the technology underneath went smaller and cheaper. And because you can then sell more, there was more studies done and more research, which made it even smaller and cheaper, until it ended in something like this. And I think that maybe the biggest and fundamental byproduct of the mobile revolution is something what we call a system on chip. For those who don't know what that means is that you have now the capabilities to put in a small little package which is smaller than your thumbnail, compute, storage, memory, sensing capabilities, and most importantly also connectivity. So you could combine analog and digital technology into something as small as that, and most importantly, it costs less than $1. And because of that, it's now not only physically, but also economically feasible to literally collect everything on this planet. So because of this technology, now we can, in principle, connect every physical device and therefore know about its state. So, and then, I mean, we have, where was it first? Our friends from Forrester and from the analysts who typically give us all of the numbers and the reasoning. Of course, if you now have billions, what's the last estimate for 2020? Is it 20 billion devices? Billions. So billions and billions of devices because of the system on chip, which you can now produce. And then in every single LED light bulb, there's one of these systems of chips, a little microcontroller inside. If they generate data at a much more explosive rate. It's actually an exponential rate than the IT systems did. IT systems created an awful lot of value, data. IoT systems will dwarf this. So what do you do? What do you need to process data? Of course, you need compute, and you need storage, and you needed to be a pretty resourceful company in the past to be able to afford this type of storage and compute, and you needed to be an even more resourceful company if you can build your own data centers. There was, next to the mobile revolution, the other revolution, We talked about this today. It's called the Internet Revolution. I think some of this has been invented also partially here at the MIT. And there is another element of the Internet Revolution which you could argue was commercialized first by Amazon Web Services. And that's the opposite of miniaturization of compute. It's poking all of the compute you think into the biggest buildings you can think of, which we call data centers nowadays, where you have almost infinite compute and storage made available to everybody. This is just a data center which we have in North Virginia, and we have 54 availability zones like this in 18 regions. So this is now all over the world. And now every individual, every startup can have supercomputing and super storage capabilities at your fingertips and spin this up in minutes. You just need an account. So you don't need to waste a lot of money in building this and get capital. So you could argue we needed the miniaturization on the one hand so that you can know the state of everything, and the maximization of compute in the cloud. So that's the cloud. That's how the cloud looks like on the other side, where you can then reason on top of that data. So I always joke saying is IoT was born when the internet revolution met the mobile revolution. So now we can do that. And then the question was, okay, what do you do with this? So what problems can you solve now that the fundamental technology actually came together? Has anybody of you heard about the so-called protein gap? Have you ever heard about the protein gap? No? Do you know what that is? So there's today roughly 7.2 billion people on the planet, I believe. And even today, there's not enough protein in food for 2 billion of them. And there is the projection, I think, which is typically accepted by most of the savvy people, that in the next 20 to 30 years, we'll go to 9 billion people. So if today we already cannot feed 2 billion, if we get another 2 billion, the protein gap will increase drastically. Estimates go to 30 to 40% of the world's population in 2040 will not have enough proteins on a daily basis. And if you know that the more richer you get, and so in the developed country, the principal source of protein is meat. And I don't know whether you knew that. I had no idea about this, but there were the companies coming and said, listen, you know, Dirk, that today 2/5 of the entire land mass on this earth is used for agriculture. But less than 50% of the plants which contain protein are actually consumed by humans. The rest, we feed the cows and the pigs, which is the source of protein, which is not enough. And the projections are that this has to double in the next 30 years. That means all our land masses, which is currently used as fields, would just feed cows. And then there's nothing left for us, neither. So that's not a sustainable solution, let alone the additional resource usage and waste of water, and then the tiny side effect of methane and other type of gases which destroy the ozone because of the byproducts that these cows do. I mean, you know what I talk about, cow shit and cow farts. But this is not a joke. There is really literal studies all over the world. How do you solve this? And there's one school of thought who thinks one of the potentially best solutions we have at this is actually not land animals, but sea animals. It's the aqua farming. And the reason why that is because it's on average 4 to 6 times more resource efficient to grow fish than it is to grow land animals. And when you look at a fish like this, it's apparently 4 to 6 times less waste in the fish, because in the cow, all the bones and everything you throw away, you can reduce and reuse almost everything in a fish. So there's now today companies, you've seen our data centers, which were so humongous, they built now aquariums the size of airplane hangars where they have millions of fish in these aquariums. Again, today, already 50% of all fish come out of these aqua farms, and believe that in 2030, almost all fish come from there. So that's one way out of this. And of course, you can imagine if you have these humongous aquariums, if just something goes wrong and you have millions of fish potentially dying, that would be catastrophic. So how do you do this? And there's a company called Pentair who's building now all of the water filtration and management system for these aquariums. And they were saying is, what we need to know at any given point in time the water quality levels, we need to understand what is the temperature, we actually have to instrument and understand what type of food goes in. They also collect, again, excuse my German Jinglish here, the fish shit, more or less, to figure out how does it work. So they actually collect the excrements out of that, and saying it's because if not, we will not be able to keep this system healthy. And the most mind-blowing part for me was, do you see the silver sides of the fish? Actually, every single fish is different. It's like the thumb print of a human being, you can identify fish. I can't. Typically, the biologists can't either, but IoT technology can today. You just need a camera, and with a little bit more advanced, what we call image recognition, you can identify these fish individually, even if there are millions. And why they need this is they need to see the entire chain of once they are born and when they are growing to understand whether they are healthy, at what stage are they, and when they can be harvested. So here, a very, very, very big problem, which will potentially touch all of us, which is only possible if you have this new technology knowing the state of everything, including the state of livestock, in order to solve some of the biggest problems. Another company in the same space, now we go back to agriculture. Trimble is a partner of ours. They started in the construction business. They just built devices which can measure distances, for example, thicknesses. And they went into diversified. They buy something like 8 to 15 companies every year. All of them do devices and aggregate them and say, okay, what if we can instrument farms, so the connected farm? And why would you do that? If you can imagine, of course, you have the sprinkler systems which go on when they need to go on. You figure out where the tractors and combines are. But the real benefit behind this is that the business model of some of these big companies have really changed. A tractor like this is what, $80,000? A combine is $500,000. And we work also with the biggest manufacturers of tractors and combines, and they said, our business model is not selling these machines anymore. What we sell is crop yield increase. They go to a farmer and said, or the aggregation that you have, it's not single individual farmers anymore, and they say, what if you can make a contract with us and I guarantee on the same land usage, same resource usage, you get 10, 20, or X% better crop yield. And how can they do this? Because these combines are very sophisticated machines nowadays. They said, if I just knew the type of grain that I'm planting, and if I knew what is the physical and chemical composition of the soil, then I knew, and then with all the data I've collected over the last decades, I could then plant it at the right depth, put the right fertilizer, put the right irrigation, and guess what? There is quite a lot of increase of crop yield. And in order to do so, they install now cameras on those combines, and when they have all of this grain going out, again, no human being would be able to do so, but image recognition, that is now live video, you can identify what type of grain, you can plant them, you need to have the systems running locally, even when they're not connected, so we'll talk a little bit about the technology like this. But at the end of the day, again, different business model in the agriculture space, increasing crop yields instead of just selling combines. Healthcare. Yet another very important topic, I guess, of humankind. So we work with a company called Philips. And Philips makes these type of machines, MRI machines, very expensive, almost in all hospitals. When you're really sick, they put you on the machine, takes an image without that they need to cut you off. And, but the most anachronistic thing in this is, still today, in most of the cases, and I know this from a personal experience because of my oldest son was actually chronically sick, and they didn't figure out what to do with him for years. What happens is you have a physician who is staring at these images and they try to figure out what's wrong with you. And it's all about what's in the head of this lady or gentleman. You could argue, how anachronistic is that? What if similar conditions have been diagnosed on the other side of the globe by the thousands? And that's exactly what Philips thought, what they built. They built what they call a Health Suite digital platform, HSDP, purely on AWS. They ingest all imagery of all of the machines they now have in all of the hospitals. They started with 15 petabytes of data. They augmented this with 390 million images and additional information they have collected over the year so that they can build now systems for the physicians in the hospital which help diagnosing what is the condition, saying with 87% probability, this is the diagnosis. And then depending on the additional, if you like, instrumentation of what type of person you are, what's your blood pressure, where are you at your stage, what is the most likely cure or medication that you should take. So again, very important problems that are, in that sense, we use them superhuman capabilities because a single human could never do that. Another one, Rio Tinto, mining company. So what do these guys do? I don't know who knows Rio Tinto. It's one of the biggest mining companies. They make big holes. Really big holes. And you see this tiny little loader there. This loader is actually bigger than a multi-story house. Only the tire is, I don't know, twice my size. And then, of course, they get all of the dirt out of the ground, and then there's iron ore or there's gold, and then they put it up. They have to go up the mine, and the mine, just going down the mine, typically is 2 to 3 miles, and then they go to something which is called a refinery, where they then try to extract the iron ore, so the value, out of the dirt. And of course, it's a mechanical and a chemical process. And what they need to make sure is that if this dirt now includes iron ore, then the factory or the refinery has to be set up to extract this type of value. If unfortunately, for whatever reason, something goes wrong in the supply chain and now dirt comes, which includes gold and not iron ore, but the factory was wrongly set up, what they do is they just dump the dirt and then they drive back. In that sense, it becomes the biggest waste whole dirt generation machinery with no value. Tons of millions of getting the dirt, driving it hundreds of miles and dumping it again. So you can imagine that in this supply chain, if something goes wrong, it's not a good idea. So, and what they figured out that these trucks, because they are so immensely heavy, every now and then break down, and typically it's the tires, and a tire just cost alone $100,000. And then you can see you can't have a different truck. So they said, okay, how can we solve that problem? And they're saying, what has this to do with IoT? So they came and they had a very simple idea. So let's put a tiny little device. It's actually something which looks like the gateway. It's an Intel gateway they used. They just glued this on one of these trucks. And I can tell you what type of software we use. It's called AWS Greengrass. And what happens is it's just measuring vibrations at 100 hertz. So 100 times a second they measure vibrations. And then they were, from a distance, able to optimize the algorithm then on the truck to generate something like a road roughness pattern. And there's very little connectivity in the mine. But whenever this truck goes up and down and they goes across a station, there's Wi-Fi, and then it can batch upload all the data. So what they were able to do is something like real-time heat maps about the road in this mine, which is humongous. And then it's like you see red, it's better drive there, and green is better driving, and they could push this to the drivers via cellular or via satellite. And they built this in just 2 weeks, were able to deploy this, and get what? They were saving millions the first day they implemented this. So a very simple, basic idea, very big economic effect from what you can do in IoT. Last but not least, typically when we think about IoT, most of us tend to think about small machines. So I just wanted to show you this machine. Do you know what this is? Any idea?
Lightweight coated paper.
Paper. This is the biggest machines that exist on the planet. These machines are typically something like 30 to 45 feet long, but they are 500 wide, but 500 yards long. 5 football fields is the size of that machine. It's most likely the biggest machine ever made, and they do paper, they do pulp transformation. You could say, okay, how difficult is it to make paper? And Kimmo, so it's a Finnish company, who explained to me, some people think you do what? You do fiber, water, a little bit of chemicals, put it together, spread it out, let it dry, ready is the paper. This machine, again, biggest machine on the planet, 5 football fields. The paper actually runs through with 60 miles an hour. So at the speed that you run on the highway, it has between 20 and 50,000 sensors just on that machine. And of sampling it, and of course you can imagine if you really do paper and tissue, and I was explained, by the way, tissue is toilet paper. So when we're talking about, there's a lot of demand not only on the one side of food, but also on the other side for paper going, and they want to optimize this, and they were saying is, okay, I need all of that sensor just to optimize the throughput. Is the quality there, is it there? And how would you do that? It's a perfect IoT use case, aggregating all of this information, getting that into a place where you can compute, having all the models for prediction, seeing how life works, and optimizing your paper process. So I just wanted to show you some of these examples, which are real. None of this is what we call pilot stage or proof of concept. They all have been built over the past few years, and were maybe also the reasons why AWS went into the IoT space, because these type of workloads were anyway running on top of our cloud, but then our customers had to build all the underlying infrastructure. And of course, there's a little way from the tiny little SoC in the cloud, and if you really want to build this up, you need this. In order to really build IoT systems from a technology perspective, it's not really trivial. But it's also not rocket science anymore. It's just technology. So how do you read this from the left side? So you see edge on top, that is the real world, real devices. You see cloud in the middle, that's more or less services and software which is built on top of that. It's just type of offerings that we as AWS do, but our competition does as well. So there is now technology like Amazon FreeRTOS that is operating systems which run on microcontrollers. Every LED light bulb has a microcontroller. There is some code in every LED light bulb. Every engine controller has this. Every thermostat at home has that. So and we talked a little bit about this. How do we make sure, if you are a startup and you're excited and you want to build something new, how do you know about security? How do you handle that? So the idea that you need to have built-in security, local connectivity, encryption mechanisms, we just said, okay, let's build some together, call this Amazon FreeRTOS. It's an operating system, it's open source, so that everybody gets benefit of that. The second thing, here what you can see, then you have gateways. You have seen some, I think the gentleman showed his gateway. These gateways, what you put onto the Rio Tinto mining truck, or what the Pentair system is using to process locally and do the classification of who is that fish. That needs logic running locally. And you ideally have the logic running in the same way and programmable for the cloud, so there's no technology, what we call AWS Greengrass. It's just nothing else than cloud functionality brought to the edge that you can compute, route information, be secure, and also state synchronization locally. And then there's a bunch of services that you need in the cloud. You need to start off connecting IoT devices to the cloud. Again, the cloud was originally built for the internet. It was for connecting computers, IT equipment, with even bigger computers in the cloud. Light bulbs or thermostats, they don't speak internet protocols. They cannot log in to a website. So things like security management, certificate management, encryption on the transport layer side, identity management, policy management, speaking the different dialects, MQTT, HTTP, WebSockets. So there's a lot of technology we need to do, but at the end of the day, it's just to make sure that these devices can be connected and managed. And we heard beforehand, and I like the gentleman saying is, you can put all the security you want into just one device. But when you have millions of them all over the world, then you have very different problems. Then it's about, how do I keep my entire health secure? Are all of my devices doing what they're supposed to do? Do they speak to the right IP addresses? What if one of these devices behaves strangely? So we put down services like IoT device management, which helps you manage your entire fleets, onboard millions of devices, finds you all the sensors in the field which are currently potentially showing the wrong readings. IoT Device Defender, which looks at behavior, like in credit card. You might have seen this. You go somewhere to a place you've never been, you pay, and then you get the SMS telling you, are you really there? Because if not, we don't do the transaction. Similar ideas here. IoT Device Defender is looking at behavior of your devices. So what if something goes wrong? What if your machine, which is normally supposed to send on your SCADA system data, is now sending something to an IP address to a foreign country? Most likely something is wrong. So it's about behavioral management after the fact, alarming. But all of this, you could say, is just for the reason of, okay, knowing the state of everything and making sure the machines work. Then you want to look at the data, and that's when services like IoT Analytics come in, where we help our customers prepare all of the data. Standard analytical tools were made for typically business analytics. So you have a lot of data coming from a few sources, financial data, for example. They're all pre-prepared. Analytics data, we have heard about this. This is noisy. You have to scrub it. You have to figure out how you enrich it. A sensor reading, it says 37. What is 37? So it's 37 degrees, 37 meters. Which devices does it come from? So there's a lot of additional data sources you need to aggregate. You need to store it in a certain way, because if you want to do some of the analytics, you cannot just have a data warehouse and do time series query. You can't do this at scale because the algorithmic doesn't fit. So what is the right mechanisms behind? And then, of course, the nirvana, which we have heard, using one of the other buzzwords that you have seen. Can I then also use all of these signals to do something which humans cannot do? Can I use what is called machine learning, which is nothing else than more sophisticated statistical modeling and fitting at large scale, so that you find patterns that human beings don't find? If you cannot describe it in an algorithm, maybe there are some patterns that the machine can just fit by enough data. And that is what we do today, either in speech recognition, so that you can more or less recognize speech like a human being, image recognition, but also in pattern recognition, which no human can do. Figuring out if something wrong in the distribution of my energy network. No human being has a sense for electricity. So you need to have different ways to doing this. That's what the machine learning does, like the Amazon SageMaker. And then the real magic happens, and that's in other capabilities we have, which we just announced by accident this week as well in San Francisco, that with the click of a button, you can have these machines learning models. They need the cloud to be trained. You need a lot of data to train them, a lot of compute. But once the models are trained, Applying them to new data, that's actually much easier. So now with the click of a button, once you learned your model, you put it all the way back to your machine via Greengrass, sitting locally on the combine, sitting locally on Rio Tinto trucks. And then you can do magic just with the click of a button, because now all of the learning is used to identify patterns without that you need to send data to the cloud. Because we talked about beforehand that there is limited bandwidth. And you cannot afford at any given point in time just send all of the data to the cloud. Sometimes you don't even have connectivity. So IoT are highly distributed systems which need to work in consultation with the cloud, but also locally. So if you see all of these services looks complicated, it is, but it's not magic anymore. There are technological solutions for that, and of course I also have a managerial slide for this. I always say this is for my engineers, this is for their bosses. It's more or less just the names, and it tells you what these services do. But at the end of the day, it's the technology that we have available in which we develop with our partners and customers, particularly what you've seen beforehand. For example, device management was developed with Philips together because they started the journey with us 3 years ago, and they started then connecting all of the devices, and I said, okay, I have millions of those. And it's fine to connect a few toothbrushes, but once I have now all my MRI machines and they had the former TV sets, it's millions and millions, so can you please help us in managing? That's why we then built device management. Or the Greengrass was because we were working with big industrial companies like Rio Tinto, who were saying is, guess what, we don't have connectivity, so you need capabilities running locally in the same way. So this is just what I wanted to convey to you. Maybe 3 things to remember. First, why is IoT real? Because the 2 fundamental things, SoCs, compute as cheap and small as possible, and the other side, compute as powerful as possible in storage, came together. Internet mobile revolution. Secondly, although it's complicated, the technology is in reality there. It is there. It's not that none of this exists. And third, at least for many companies, not for all, of course, it is already real in deployment. So it's not something which we put on slides. On a few years ago we did. Now there is less and less just talking. There's more and more just value creation. And with that, I just have my last slide saying is now that you can know the state of everything, and you can reason on top of that data, what problems will you solve? Thank you very much.
So we will do some Q&A, of course. The future has arrived. I think you pointed that out last night, obviously, and so I think for upcoming versions of this, we'll use the past tense rather than arrives or arriving. Or,
at least for IoT. For the
yes.
other buzzwords, I can't talk, but for this one, yes, I believe so.
No, so that was great. So we have some time for questions, and I know Ken always has a question. I'm sure Frank Gillette will probably have 12 questions, but I'd like to see if there's some other folks. I know Dirk just gave a very complete vision. Questions. We're not going to do the file cards. We'll just do questions. Right there on the left. My left, you. Okay.
Well, thank you very much for your presentation. A quick question about how you see the networks that will support the next generation of these IoT technologies, specifically with AWS Greengrass. We're talking about Pentair with about 15 petabytes of data being processed.
That was Philips.
Philips.
But
okay.
Pentair most likely will have as much data soon.
So you have significant amounts of data,
yeah.
and some of them could be processed locally.
Yeah.
Some need some of that hyperscale core data center functionality. How is that going to continue? Because we're going to see more data being used and generated when you have these new mission-critical applications. I mean, we haven't even touched the world of autonomous vehicles or augmented reality and all the different use cases that will go on top of that. So just curious to get your thoughts, and AWS is a driver in that space, how you see that evolving.
So you hit the nail on the head, as I would say, is the generation of data happens at a faster scale than there is reduction in bandwidth cost. And what we made sense of with our customers saying is we call this the 3 laws. There are 3 laws. One is the law of physics. And it means is the speed of light is only as fast. So for example, if you're in a factory and you have a robot moving, and you have this big red button, and you hit the button because you want the robot to start in sub-milliseconds because otherwise maybe human beings get in harm. You want this to happen immediately. You can't afford a round-trip delay sending that to a data center, which is maybe still in your state, but coming back and forth, and it's 50 milliseconds gone. Or the Rio Tinto case, if there is no network connectivity whatsoever, there's simply no connectivity. And we believe, we call them laws because they will still be valid also with the advance of technology. As long as there is still Einstein and the speed of light is the speed of light, we believe that will still be true. So there are many use cases where you don't have connectivity or speed. You talked about autonomous driving is of matter. You need to do local compute. The second law which we identify, we call this the law of economics. And it's exactly what I said beforehand. If you have exponential growth of data, but you have now slowing down cost of transmission, of course there's a mismatch. It's simply too expensive to send all of this up. We have one customer who is doing jet engines, and a modern jet engine produces 4 terabytes of data 1 hour. 4 engines on a jet, just going through, you have 100 terabytes per flight. Try to ingest 100 terabytes of data. Ain't gonna happen, it's by far too expensive. So the idea of that you need to pre-process something locally so that you only create the valuable data and put it then via the transmission channel. And the last and not least, and we talked a little bit when Nora was here about what's happening in Dubai, we call this the law of the land. There are actual laws prohibiting you certain things. I mean, we talk about GDPR in Germany and Europe. We talk about HIPAA laws. So a certain amount of data you're simply not allowed to transfer. So as long as you believe that these three will coexist, we needed to figure out a way with our customers, how can you take benefit of the cloud but do local compute? And the reason how we developed Greengrass, and that's maybe then, again, that gets a little bit technically now, but the reason why we developed this in the first place was, how can you combine the local compute and the cloud? Local compute is called embedded development. That's, again, mobile phones, you did this a lot. But it's a different type of programming than we look into the cloud. So the idea was, can I find the same way where the same messages and the same triggers and the same actions and the same security paradigms can be used across the cloud and the device? And that's what Greengrass does. It more or less gives you a local runtime where you have local Lambda function. It's a serverless compute from Amazon. You have local message triggers. You have state synchronization and the same security postures that we demand in the cloud all locally. And the benefit of this was, and Rio Tinto was the best case, you only have to touch something like the device once. You put once the capabilities in like we did with the Rio Tinto trucks. And then you don't have to touch it anymore because from the cloud you can then put new logic onto this. You can monitor at any given point in time. And when it's then offline, it still works. And when it gets online on, it automatically synchronizes. So the idea was embracing that these are very important use cases. They won't go away. They will be there forever. So we're just trying to find a technical solution to that instead of pretending, no, it's not, it ain't going to happen. It is for real, the three laws. So find a technical solution that you can cover them.
Question in the back.
Hi. Yeah, you gave a lot of great examples from different industries, but can you tell us which industries are leading adoption of IoT, which ones are lagging?
Okay.
And then selfish interest, where does clean energy fit into that scale?
So I get this a lot. The best and most honest answer is none. None is leading in everybody. It's not about the industry. It's about the, how shall I say this without offending? It's about the state of mind and culture and situation of the rabbits, I call them the rabbits, in the industries. We have, through all industries, I have companies who are really at the forefront, who really embrace it for multiple reasons. Some of them just because they are startups innovative. Others because they are with a back to the wall and they figure out if I don't change, I will just disappear. And others just had the foresight. So I cannot say the industrial IoT is leading. Of course, industrial was the birthplace of IoT. It was just called machine to machine. In that sense, but that's not what I mean. I mean, all of the industrial companies do, everybody who does production. I mean, Amazon ourselves, our fulfillment centers, most likely some of the biggest IoT use cases that you can think of. And then you just had to build this yourself. So there are many siloed solutions available. And I mean, we saw the colleague of GE, which is also now helping all of those customers to more generalize this. So, but the power of IoT, where you don't have to be just this behemoth who has to invest millions of dollars in years, that you can more or less do this from the smallest company to the largest and taking benefit of this new technology, that you can see spread across, at least to my experience, all of the different industry. So it's not an industry phenomenon, it's a stage of what the companies are in. And again, the reasons why they are adapting this faster are manifold, from negative reasons to survival to very positive of innovations. But I mean, we are still far from big market penetration. If I had to say, that's why I call them the rabbits, it's just still the early adopters who are really in production. So there's a far way and a long way still to go.
All right, we have time for, I think, 3 quick questions. I know Ken, because, you know, he's Ken.
Yeah, and I'm outside as well. You can ask me afterwards.
Yeah, that's
no
right.
worries.
Ken, please.
So, first of all, Karlsruhe is a great place to be from.
And a great university, too.
So, you mentioned industries, and you said it's rabbits within the industry who either are doing it because their backs are to the wall or because they're early adopters of it. What about geographies? Because when I think of Japan, I think of other places, it seems to be harder for them to innovate, or is that not what you're finding?
So I have an official answer and I have a personal answer. Which one do you want?
Both, yeah.
Okay, let's start with my personal answer. I'm a European. I'm not from Karlsruhe, I just did my PhD there. So my mother's from Germany, my father's from Greece. But I spent a lot of my career in Asia, so in China, and to the United States. And if you ask me, is one of the continents behind? Yeah, it's Europe. So I felt when I started this journey, being in China and seeing what type of technology development and what innovation power there is, and now also in the United States, of course, me now living on the West Coast and working for one of these apparently most innovative companies of the world, called Amazon, you just see the speed of innovation and the embrace. And there's no wonder the GDPR was first invented in Europe. And I'm not saying it's bad, I'm just saying is, when I went even 3 years ago to what is called, it's not Davos, but it's a different summit that they do every 2 years in Finland for the Nordic countries. The entire spirit of the discussion was not what benefits do these technologies bring, but what dangers lie in them. So, and that just shows you a little bit the spirit. I'm sorry, I wanted to go back and some of my friends which are in executive position and then share, do you know what's ongoing on both sides of the world, either in China or in the United States? I believe the Europeans have figured that out. Specifically now, they are trying to catch up. France, for example, again, similar thing. Most likely, first you have to shatter your economy before you make the leapfrog. I think they are now really aggressive in doing this. The Germans are waking up. I mean, we see a lot in Korea, which is working. I have less insights, to be honest, about what's happening in Africa. But I was just told on a very different level for a good friend of mine who is still working at Microsoft, more or less in a similar position of me, that there is also a ton of innovation going on there, but of course on a different level, because there it's really about how can I do systems without the money, without the infrastructure. So a lot of innovation there. So, but if I had to say, I believe the United States and specifically China and the greater China are leading here. And to my own, I'll say sorrow, I felt that Europe is unfortunately still a little bit behind. In between, I think both. So we have some very leading edge in Japan with very good partnerships in Japan, and again, some very traditional companies.
So, Nadia, I'm afraid we can't do any more questions. Frank?
I'm standing outside, you can ask me in a given moment.
Frank, are you stretching or are you just trying to, because I've been given the hook on that, because we've got a very good panel from my good friend Andrew Hammond, who's going to come up and talk all about security. Can you do, is it like a quick, like a 1 second question, Frank? Okay, time's up.
Is it capabilities or is it use cases? I find companies don't lead, it's
Andrew, start
individual
coming up.
business leaders.
Fair. It's all human beings. So there is no such thing like a company. There's people in companies. So it's about culture, and therefore it's about people. Yeah, good clarification.
Thank you, Dirk.
Thank you.
Keep answering questions.